Okay, I'm going to share the screen. Okay, so we are recording now. We're still working on the wine data set, right? And we want to basically get a model that's as good as possible. We know we've already gone over the R square, which remember is called the coefficient of determination. And this is the metric that we're using to measure performance. I believe someone had gotten to like 0.34, correct? That seemed to have been the highest value. Okay, so there's a couple of things that we're going to try today. One of them is today is a good day to introduce a program called WEKA, W-E-K-A. It's an open source tool. I always show it in all my classes. It's very easy to learn. I mean, you can learn it literally in one lecture. Just go ahead and download it from the web. All right. As I said, it's called WEKA. I already have it installed on my computer, so it's just going to be this program here. So it stands for the WEKA Environment for Knowledge Analysis. And this has been around since 1999. But it's a really nice tool. It's written in Java and it's very GUI centric. Okay, so this doesn't require any coding. All right, so I'm going to use this tool. As I said, you can see it here. I'm going to create this video as, regression with WEKA, basically, right? And you can look it up there. Just download it. It's built in New Zealand by the University of Waikato, I assume. And it's, it's pretty good. I always like to use it for fast prototyping, right? And basically, in this case, we have a regression problem. We have wine data, and we want to see how well we can do, right? So, all right, so let's go ahead. So you click on the Explorer. And then we get this screen here. Okay, and we're going to load the file. So I'm going to click on Open File. And then this should be in the desktop. So we're going to go to the desktop. And then you guys are section 2. So we're going to go to section 2. And then under data here, right? This is where our iris data set lives. So you have to select CSV. If you don't select CSV, it doesn't load it. So it likes to know what the extension is. All right, so then you click on wine quality. Click open. It's giving us that semicolon problem that we had before with pandas as well, if you remember. So you just click on use converter, okay? And then there should be a field separator. I believe that's a comma there. So just change it to a semicolon, right? Which is the delimiter that this is using. Click OK, and it is loaded. It's a very nice tool. It's one of those, think of, you have a toolbox, right, for machine learning, and just add this one as well to your toolbox. Very nice. So we have, it's good for quick visualization, quick prototyping. Guys over there, any questions? All right, so we know that the quality is the thing that we're trying to predict. We want to take a look at all the variables here to make sure that they are all numeric for this type of problem. So if we look at, I'm going to click at all of them here. And I'm going to check this little field here where I'm moving the mouse, where it says type. And we just want to, oh yeah, go ahead, please. Huh? You're trying to install it? You want me to wait for it? Okay, you want to follow along? Okay. All right. Yeah. Should be able to download it from, it's free. You got it? Yeah, just double click on Windows and all right. So anyway, so the idea is, if you remember, we had 12 fields and the last one is the value we're predicting. So I'll kind of just repeat the key thing. This is a regression problem. And for regression problems, you want to make sure that the quality variable is numeric. Okay, this is really important. Okay. And then check all the other variables and make sure that the type is numeric for all of them. So just numeric, 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 and numeric. So they're all numeric, okay? So that's basically the main thing. Any questions? Everyone with me? Issues? Everyone's caught up, or are you guys still? Do you want me to start again? Sure. All right. All right. So I'll close it and I'll reload it again. Okay. All right. So I'll open WEKA. Okay. Let it load. It's got a lot of features, but we're only exploring one. Click on Explorer, the Explorer button. That opens this window. WEKA is written in Java, I believe, but we don't have to code. It's just a GUI interface for quick prototyping. Go ahead and click on Open File. Then we're going to navigate to the desktop, which is where we have our file, the wine data. You guys are section 2. I'm going to go into data, and you have to specify the data type. So the default data type for WEKA is something called .arf, but we can load CSV files. So you click on that. You can see wine quality data there. So just go ahead and click on that one. And it gives us that same error we had with pandas, the semicolon issue. So you can just click on use converter and field separator. I think that's a comma, so just change that to a semicolon. And then once you click OK, it should load your data with no issues. Any questions? All right. So again, the idea here is, you're building neural networks, and that can be complicated. So we want to try other things, right? Very simple things. Now in PyTorch, we built a linear regression. We have linear regression here, but this is like a profound thing that hopefully you guys will learn about when dealing with regression data of a specific type. Now in machine learning, this data set, regression data like this, is called tabular data. Guys over there, do you have any questions? Over there, you two, do you have any questions? All right, so we've loaded this data, our regression data or tabular data. So the key thing is when we're predicting, the variable that we're trying to predict is quality, right? So that needs to be numeric in regression and in WEKA in particular. So what we want to do here is we just want to check the data types. So if you look, I'm checking acidity is numeric, volatile acidity is numeric, citric acid is numeric, residual is numeric, chlorides are numeric, sulfur dioxide is numeric, this other sulfur dioxide is numeric, density is numeric, pH numeric, sulfates, alcohol, and then in particular, this one is really important that it should be numeric. If it's not numeric, the regression models will not be available to you. It's like by default, WEKA, kind of guesses what you're trying to do by this variable. All right, and then it's got a lot of features, like you can visualize the distributions, etc., but we don't have to worry about that right now. Instead, what we want to do is we want to build regression models like the ones we've been building with PyTorch, right? But we want to do it quickly and more broadly, right? In fact, WEKA doesn't really have deep learning. Instead, we're bringing in other tools by default, I should say. You can add a lot of things. There are other techniques for regression, right? Linear regression, obviously, is one, but there's trees. Like decision trees, regression trees. There's something called XGBoost that's very exciting and we'll play with today. That's actually the last thing that we'll take a look at. There's support vector regression, which is like a version of support vector machines. So there's a lot of tools for regression. Again, in machine learning, regression problems are generally called tabular problems. Unlike a lot of things that we do in machine learning and deep learning, our data sets are small, right? This wine data set is small, 5,000 samples, 11 features, one output, right? It's small, it's tiny. And you guys are doing this experiment, but we're going to hopefully come to the same conclusion that has been found in the literature, that sometimes regression models, regression trees can be very good for regression problems. Okay, does that make sense? All right, so today I'm not going to go over theory of regression models. Probably do that next week, but I just want to give you all the tools that you can throw at this problem, so that in the end, our goal is to get the highest possible R square that we can get. All right, so let's take a look at WEKA. So now that we have our data and we made sure that everything was numeric, all you have to do is you go to classify, which is this tab over here at the top, click on it. And if you remember, now we can do a split like we've been doing, the 66 or 80% split, but I think I told you that tenfold cross-validation is a better approach, right? Because you're going to repeat the experiment 10 times every time you're randomizing the data and splitting differently, okay? So let's use cross-validation, and let's just run this data set through all the regression techniques that we have available in WEKA. For such a small data set, this makes sense. Run it because you're starting to establish what are the baselines, what are the minimum values that we can get. And then finally, maybe there's one breakout model in here, right, that gives us some intuition as to how high we can get, given that our PyTorch models are much more complicated to build. All right. Okay. Any questions so far? All right. So let's start then. All right. So the techniques are in this button here that says choose. Okay. We already said we're doing tenfold cross-validation. Another very important thing is make sure that the variable here is quality. This is the variable we are trying to predict. Okay. So if you notice, of all of these, which are all numeric, make sure you select quality. Okay. Yeah. So it says select the attribute to use as the class, but here's the regression values. Just that's how WEKA does it. All right. So now let's go. If you click on choose, it gives you this menu of all the models that it has available by default. You can always add more. Okay. So I was playing with this afternoon. So obviously I know which one's the best, and I will intentionally select that one last. But let's just go through them. Okay. So there's Bayesian models, but none of them seem to be implemented for regression in WEKA, right? So there's nothing, because you can see they're not highlighted. So that means they're only for classification. Now in functions, we have a few, like linear regression. We've already applied that model, right? We applied it with PyTorch. There's a multi-layer perceptron. That's the MLP that we tried before, right? So you can compare the result of this to what you're getting in PyTorch, right? Remember, that's one input, one output, and one hidden layer. SMO regression, I believe this is support vector regression, actually. So it should, yeah, SVM for regression, right? So we can try that one as well. That's another technique. There's quite a bit of theory that goes into support vector regression, so I may not cover that in this semester. It's been kind of replaced by deep learning, basically. So, but we have these methods. So let's go ahead, and then there's a few KNN, but I won't implement KNN or use KNN rather. In these meta ones, I'm going to skip those. But I am interested in a few of these function ones, and I'm interested in the trees ones. Okay, the models based on trees. All right, so I'm going to go ahead and start with linear regression. Okay, so if you notice what I did, right? So hopefully you notice what I did. Just click on linear regression, use default parameters, and go ahead and click start. All right, and as you can see, it gives us already the value. It's really quick. correlation coefficient is 0.52. So that is the R, not the R square, right, that we're using, which is, so the correlation coefficient and the coefficient of determination are related, but they're not the same. So basically this one coefficient, correlation coefficient, you could call as R, right? So then therefore to get R square, you just have to square this one, right? So really the value that we get, I'm just using my phone here, 0.52 times 0.52, right? What is that? 0.27 or something? Yeah, can you guys corroborate? Yeah, 0.27, right? All right, which is in line with what we've been getting, right? That's actually, I think, what we got for linear regression, as you can see. So it's not like we're making any mistakes, it's just, it's difficult, right? All right, so let's try another one. Multi-layer perceptron, that's the MLP one. So hit that one. This one will take a little bit longer because it's a neural network. And we just want to see that correlation coefficient and then square it. But as I said, what we're doing is like benchmarking or establishing a baseline, and we just want to see the range of how good things can get. Because we're doing tenfold cross-validation, this is actually pretty good. It's a very solid metric, right? You can see when the little bird is doing that, it's training. All right, it finished already. The correlation coefficient is 0.52. So 0.52 times 0.52, 0.27. We're same, right? And it's in line with our MLPs, right? They were around that. You know, we're kind of stuck at 0.30. All right, let's try another one. Support vector regression. As I said, this one is powerful, but it's a different type of an algorithm. And let's just see what it does. It's thinking there. Okay, so it's coming. As you can see, this one's taking a while. Remember, it's doing 10 times the training, right? So it's doing it 10 times what we've only done once. PyTorch. Okay. Okay, so far we've done linear regression, multi-layer perceptron. Those are two models we had done already in PyTorch. Support vector regression we did not do, of course, because it's a different type of technique. But let's see what we get. Did it finish for any of you? No. It finished for you?
0.52.
The correlation coefficient?
R is 0.5.
The R. So you need to square it. It's gonna be like 27, 30. Yeah. Yeah. So you're maybe at this point starting to feel discouraged, right? You'll never be able to get a better model, but we'll see. Okay, there it is. 0.52. So 0.52 squared. 0.27. We're kind of stuck there, right? This is a lot of like firepower, right? We're throwing a lot of algorithms really quickly. Remember, this is for quick prototyping. So let's take a look at, all right, so we've kind of finished these function ones, right? So let's take a look at trees. Trees are a very interesting thing, right? And so that, I will cover trees, as I said in this course, even though the main focus is neural nets, just because in machine learning, it's like this. Every now and then, there's something that's interesting, okay, that does things better. So I ran this several times. So let's take a look, right? So I'm gonna do the decision. All of these are trees. Some of them are shorter, some of them are more refined. Let's do this stump one, 0.39. So you can imagine that's not great. Yeah, so that's 15, right? Let's try another one. This M5P. 0.58, kind of the same, right? That's 33, so that, okay, some improvement, although we haven't beaten what we had before in our PyTorch models. Now remember, these are significant results because we're doing it 10 times with different randomization of the data. Let's try the random tree. 0.57, so we know kind of what that is. And let's do the final one, which is a random forest. Huh?
0.74,
Right. So that's interesting, right? Random forest, after doing all these experiments, if we take a look at random forest, and basically there's something called decision trees, and random forest is multiple decision trees. That's why it's a forest of trees. Yeah, so square it, right? So you need to take that, so 0.74 times 0.74, 0.54. This is definitely a significantly higher value than our close to 40 we had before. You go to a competition, all of you are getting 0.40 with your fancy PyTorch, and then somebody comes in with a random forest and gets 54. That's a 0.14 higher, right? You see that? I mean, in terms of the competition, that's significant. So this is why this is important. Trees are important. These are called regression trees. And so remember that. Let's, please make a note of it, right? We got like 0.54. 0.54, okay? So this is what's great about a tool like WEKA. Really quickly, it took us like maybe 15 minutes, 20 minutes, and we're able to try several algorithms, and we've established that it might be possible to get 0.54 R square, okay, in our process. Now you know that there might be a neural network architecture for your homework assignment that could get you 0.54 R squared. Do you see that? That's the number to beat in a sense. You guys understand? All right. So that's kind of WEKA. That's basically it as far as WEKA. And so this was really, as I said, just to establish like a higher limit. What would be the, what can we achieve? So are there any questions with WEKA before I move on? Yeah. Yeah. Either one.
Yeah. So I just wanted to know that can you teaching out the random forest on how it actually works in PyTorch?
In PyTorch, no, we won't implement this in code. What I will show you in a second is it's a regression tree in Python, but we don't really code that much actually. And the algorithm is quite complex, but I will cover the algorithm in theory probably next week. So yeah, go ahead.
I was just gonna ask if the random tree is a bunch of random regression.
It's a tree. It's literally a tree. It's a tree of decisions. So I will go over some theory, right?
Okay.
But basically it's like there's a decision. It's like a binary tree. It is like a binary tree. So I promise that we will cover some theory of regression. And it's, yeah, as you said, actually, it's a binary tree where you have nodes that have values and nodes that are decision points. And the decision points are based on features. So it's like if feature alcohol is less than this or greater than this, then go in this direction or that direction. And you keep doing that until you get to the specific node, and that node gives you a value called a residual, and from there you calculate the value.
Like something similar to like dropout on what we did.
It's not a neural network. It's a tree, a decision tree, like a binary tree. Based on the features, and some of the nodes have values to predict, like the regression, the quality. So we will cover, as I said, some of the theory of this next week, okay? But I don't plan to implement the code. I mean, let me think about it, I guess, but I'll show you one more tool of this, okay? Any other questions, guys? But it's not a neural net, I insist, it's not a neural net, okay? Yeah, please, go ahead. Let's see, that's a very good question, right? It's limited by your RAM. So there's a limit on RAM right now, but there's a parameter in WEKA that lets you change it a little bit. So you can increase this to like 6 gigabytes of RAM. So I have tested WEKA with maybe like 100,000 samples by 1,000 columns. Maybe it was 10,000 columns, but I don't remember. So with 6 GB of RAM, you may be able to load a matrix that is 100,000 by 10,000, or maybe 100,000 by 1,000. I can't remember which one, but so yeah, it's a prototyping tool, okay? Not for deep learning necessarily, although they've I know that they've been working on upgrading it to deep learning, so it may have new features now, okay? But I just use this tool for quick prototyping. So we're gonna see that it's not really, I'm not saying that this is better than deep learning. I'm just saying that for some problems, right, there may be other tools other than deep learning, especially tabular data. That's why I kept insisting when you have small data sets, and especially like regression type data sets, it has been found in competitions and literature that some of these techniques, in particular, regression trees, do well. So it's good to never forget that, right? If you get a data set like this one that predicts regression, it's kind of small, try a regression tree, okay? And we've seen already, we experimentally got a good result here. Got it? All right, so this concludes the WEKA part, at least for regression. We may come back to WEKA later in the semester for classification. Again, we're going to do prototyping with it, or for other things, right? WEKA is a useful tool. Just add it to your toolbox and keep it there. Okay, got it? Any questions? All right, so I'm gonna close this. We already established what we wanted, right? Which is that we may be able to achieve 0.54, right? So let's remember that one. Okay, so I'm gonna close WEKA. So just click yes, and you can close this one. Yes, I'm gonna stop sharing. I'm going to